Hello everyone, welcome to the notes on limits. There's a lot in this section, it covers a lot of material, but the best thing I can tell you, if you forget everything else and you can remember one thing about limits, remember this: a limit is a y value. Okay? So, there's three ways we can make a limit. You can create a table, which we're going to use our calculator to do. You can draw a graph, or sometimes the graph is given to you. Or you can use algebra. This is the most common type of problem we're going to see. Using an algebra will be sometimes difficult, and you'll see more of that when you get into calculus. But for now, let's just do some basic ones. This is how you write a limit. You read that as the limit of f of x as x approaches c is L. So sometimes it'll be like as x approaches 4 equals 12 or something like that. Finding limits graphically. Okay? This is the easiest way. Determine the limit of x squared as x approaches 2. So graphically, let's draw the graph. You can see the parabola. If you see it, it says from the left, from the right, and then the limit. Imagine that you're a guy. You're walking from the left side. As you get closer to 2, you get closer and closer to that point right there. Well, what is the y value of that point? If you come from the left, the y value is 4. Notice that this 2 has a little negative beside it. That means we're coming to 2 from the negative side, from the left. How about from the right? Now your little stick figure is on the right side, and he's following along. He's going to the same point. What y value is he getting closer to at that point? 4. So how do we say that? The limit of x squared as x approaches to positive, because 2 from the right side, from the positive side, equals 4. So since the left side is going to 4 and the right side is going to 4, you can say the overall limit, not 2 plus or 2 minus, just 2, is 4. And it makes sense. An easy way to think about it is, that's the point, 2 comma 4. Now that's not always going to work. The point isn't always the limit, but in this case it is. Remember, it's where you're going to, not where you actually get to. So this is saying as you approach the point 2. So this guy coming from the left and this guy coming from the right are both approaching this hole. What's the y value of that hole? The y value of that hole is 2. Now that's a very different question than this question. This question says, where does the function exist at x equals 2? Well, at x equals 2, the function isn't the hole, the function is the point. What's the y value of the point? 1. So here's a good example where the point and the limit aren't the same. One-sided limits we talked about earlier are from the left side or the right side. So this wants to know what's going on 2 from the left side. So I'm coming from the left side, I'm going there. That is going to that hole, and the value of that hole is 1. 2 from the right side, 2 plus, 2 positive, come from this side. I'm also going to the same hole, and the y value there is 1. This is saying, where is the point at 2? There is no point at 2. In this space right here, here's x equals 2, there's only a hole, there's not a point. So there is no point, it does not exist. Since these two things are the same, the left-hand limit and the right-hand limit are the same, then the limit, just x approaches 2, not negative or positive, just x approaches 2, is also 1. But let's contrast that with this problem. How about 1 from the left? And sometimes it's easier if you make a big circle around the x value. So that's x equals 1, all the stuff in there. If you come from the left side, you're going to that hole. What's the y value of that hole? 0. If you go to 1 from the right side, you're going to that point. What's the y value of that point? Well, it's 1. Notice they didn't go to the same place, so they don't have the same limit. What's the point at 1? The point is here. It's at 1. These two are not the same. Because the left side and the right side aren't going to the same place, then the limit, the overall limit, does not exist. Summary there. The left side will always exist. The right side will always exist. But the limit might not exist, only if these two are the same. Limits can fail to exist in 3 situations. The first we just talked about. The right side of the graph approaches a different value than the left side of the graph. Unbounded behavior. Easy example, that's an asymptote. There is no limit at 0. There's an asymptote there. One side's going up forever, one side's going down forever. And oscillating behavior. This graph is much harder to draw. It's something that wiggles like that. You will almost never see an example like that, so we will stick to these 2 examples the most. How do I use a table to find it? Well, I'm going to zoom in on the table. If I make a table like this, here's my equation. I want to know what happens as you get close to -1. I'm counting by really small x values. Look at your y values. As they come into the middle, what are they getting really close to? Well, they're getting really, really close to -0.333. The correct answer is -1/3. The table doesn't tell you the answer, but it makes it pretty obvious what the answer is going to be. So how can I use my calculator to do this? Well, I'm going to go to y equals and type in the equation. I'm going to go to table set, which is second window. Second window. Enter the limit as your table start value. So in this case, I wanted x equals -1. I would use -1. And then under delta table, which will look like this, I'm going to use a really small number. In this example, I use 0.0001. You can also use 0.000001 or whatever small number you want to. And then look at the table. And just look what value is right here in the middle, the value we're trying to get close to. Oh look, these are going close to -0.3 repeating. These are getting close to -0.3 repeating. So the answer is probably -0.3 repeating, which is -1/3. The third type, algebraically. This is where we'll spend most of our time. Okay? Direct substitution is valid for all polynomial and rational functions with non-zero denominators. So, ask yourself, are you dividing by 0? If the answer to that question is no, we're just going to plug in whatever x is approaching. Okay? If we're not dividing by 0, then all we're going to do is plug in whatever x is approaching. What happens if you get 0 and 0? Then we have some sort of common factor. If we get 0 over 0 when we plug in, that means we need to have more work to do. As a side note, if you get a number over 0, you can just go ahead and say that limit doesn't exist because it's going to an asymptote. But 0 over 0 is the one that we just spend most of our time with because that means we have more work to do. So let's try this problem. I don't see any division by 0 in this problem, so take 0, plug it straight in. 0 squared plus 9, well that's square root of 9, and that is 3. It's just that simple. So now we run into a problem. If I plug in 1, I'll get 1 plus 2 minus 3 over 1 minus 1, which is 0 over 0. 0 over 0 isn't 0. 0 over 0 does not exist. It means more work needs to be done. I'm going to factor the top. Now what do you see that can happen? Well, I can cancel here and here. Now I have just x plus 3. I canceled out the x minus 1. Take this, plug it in right here. If you plug in 1, you're going to get 4. What's that look like on a graph? How does that happen on a graph? Your graph's going to look like this. It's going to be a line that goes through the y-intercept of y equals 1. Draw that a little bit better. Or y equals 3. Yeah, close enough. Except it's going to have a hole right here at 1. That's why the graph doesn't exist. That's why we ended up with 0 over 0 when we plugged it in. But the limit exists, because you can see that both sides are going to the same place. What about here? Well, if I plug in 1, I get 0 on top, I get 0 on the bottom. That's bad news. It means I have more work I need to do. I use this example because it shows you need to know how to factor. All those rules for factoring that you learned in Algebra 2 don't go away. Factor and cancel. Now plug in whatever you're missing. You get your answer. Just so, important things for limits. Look for y values. On a graph, it's where you're going. And not necessarily the point. Okay? On a table, we're going to use the calc. And we're going to zoom in on the table by having a small delta table. We're going to zoom very far in. As an equation, as a function, we're just going to plug in. If we get 0 over 0, we're going to factor and try again. Those are all the simple types of limits. The next video will show more complicated ways to do limits.